We're going to review the exercise related to strings that we worked on during last class session. So we have been doing some student-led live coding during the session, exploring various solutions that you came up with. Now what we're going to do is we're going to use this video recording to provide you with not only the direct solution, but more like a process to come up with a solution, which will be like instructor-led. So let's get started. There are going to be like several videos, each relatively short, and each one of them is going to address one of these exercises. So the first one will take care of the string length function, then string compare, then string allocate, and we're going to keep progressing like that in the exercise that we already worked on in class. Okay, so this first video will be focused on implementing the function strLength. Let me switch directly to kwrite. I already opened a file named main.c, which we're going to use to implement all of those string related functions. As you can see above here, I already have the prototype of the function. Here it's a declaration. I have its definition ready to be filled in right here. So let's move ahead. The easiest way to implement this problem, of course, is to use a loop. Okay, so who says loop says I'm going to need an index, int I equals 0. What is my condition? Well, I'm going to iterate over the string. Okay, so I choose to use the string to address each element of the string using an array notation. And I'm going to say while s index I is different than the character null. Little typo here. While s index I is different than the character null, I'm going to do what? Well, I'm going to, at some point, hopefully increment my index I, otherwise this is going to be an infinite loop. And then I stop and I have to think about what else I need to do in the body of this loop. In this particular case, well, as long as s of I is different than the character null, the mark of end of string, well, I just have to keep going as a string, and that's it. Once I exit my loop, I will have here, in the value of I will have the length of my string, and I can return that as a result of my function. A couple of things that we can change here in this code. The character \0, the mark of end of string, is encoded as the value 0. So I could choose to compare s of I with character \0, as I did here, or I could compare it to the value 0. I could also compare it to the constant null, which is equal to 0. Or, if I remember that in the C language everything that is 0 is false, then I could simply replace s of I different than 0, which means different than false, by simply while s of I. And that simplifies a little my condition. Okay. I really recommend that you always put opening and closing curly brace for each block of code, whether it is the body of a loop, the body of a if, else, or the body of a function. Of course, this one is mandatory. If you want, you can, however, remove those curly braces here, since we have only one statement in our while loop. Okay, so that's not necessary. Of course, that's just like rewriting the code differently. I'm trying to show to you here different syntaxes. The body of my loop is only composed of one statement right now, just I++. Well, if I wanted, I could even remove that statement and put inside of the condition of the loop itself a post incrementation of the index I. So you will notice here that I have an empty loop. Okay, semicolon closes the loop immediately, and this is pretty much all I need to do for this function. So we are going to save it. I'm going to compile it. Let me switch to my terminal. gcc main.c. Okay, execute a.out. Okay, everything compiles, link, execute. However, there's nothing yet in the main. So let's go ahead. I'm going to click here, and we're going to test this function. So first I need a string to work on. So let's make a basic string here. We'll call it s1. S1 will be initialized to high. Then I will have a simple printf statement. The length of the string, I'm neutralizing a double quote here so that it appears on the screen as a double quote. The length of the screen of the string %s, neutralize another double quote, is, insert an integer \n for a new line, comma, The first value provided to printf will be a string, and I'm going to use s1. The second value will be the length of the string, and that is going to be returned by calling str length of s1. And I close the parentheses for the printf, semicolon, and we are in good shape. Let's do a return 0 to be really clean programmer. Control S to save your file. Switch back to the terminal. Let's try again. GCC. Warning, initialization makes integer from pointer without a cast, so line 9 we go back to line number 9. We have here a lot of windows opening randomly. We have here char s1 equal I, char star s1 equal I is what I meant to do. We declare a pointer on a character and we initialize it with the address of the string later on. What caused the warning in the compilation that we just seen is simply that if s1 is a char, that means it is meant to hold a small integer value, pretty much. This is how chars are implemented. A char is nothing but an index in the ASCII table with value between 0 and 255. So I'm trying to assign to this char, the small int unsigned value, the address of the string, which is a 4-byte constant. So this is what caused the compilation warning that we saw previously. Let's save again. Switch back to the console. Of course, because my char was wrongly defined, you can see here that when I called the strlength function, the compiler was complaining about the fact that the parameter was not exactly of the type that was expected. This should be fixed now. Let's try again. gcc main.c, everything is working. Execute a.out. The length of the string I is 3. So our code is measuring the length of the string, including the trailing \0 character, which represents the mark-off end of string. Let's go back to the code real fast. If we don't want to include counting this end of string mark, we can simply return I minus 1. Okay, we don't even have to really modify the logic of the loop itself. Over comment, we have been using here the array notation. What if I wanted to rewrite the same code using actually pointer notation? Well, this would be relatively easy. Star for dereferencing. What is the address I want to dereference? S, which is the start of the string, plus I++. And I'm getting rid here of the square bracket notation. And this would be it. So let's save again. Compile. Execute. Still working. Okay, it's just a different way to do the same job. Last version I can think of the top of my head. We have here char star s, which is a parameter, therefore it's a stack variable or local variable of the strlength function, which means I can modify this pointer without affecting anything else in the main, for example. Be careful about this remark. You remember that to be doing parameter passing by reference in C, you need to pass the address of an object. However, the pointer that you pass can be modified, and it's a local variable, so that's not going to affect anything in the main. The only real way to do parameter passing by reference is to not only pass the address of an object, but also dereference this address inside of your function so that you access it. Okay. So here I'm just going to play with the local variable s, and that is all. So while star s, as long as star s is true, okay, so the character pointed at address s, I'm going to go to the next character. So I'm going to do s++. So post incrementation again, and this time it matters here if I do ++s or s++. Okay, so be careful about that. And what can I do for the size, because I'm still not counting the size here. So I'm going to use a little variable in size equals 0, and in the body of my loop I'm going to simply increment size every time I can proceed to the next character. I save, switch back to my terminal, compile. I is undeclared, go back to my code. Yes, I've been leaving here, return I. So we need to change that to size as well. Compile again, working, execute. The length of the string I is 2. So go back to the code. Yeah, this time we are like stopping before we actually count the end of string marker. It's simply because we first test this condition, and then we increment size if necessary. In the previous version, we had here inside of the condition itself, we had something like this, I plus plus. So that means that when we evaluate the condition, well, is S of I a valid character, a non-terminating character? Well, when I evaluate this expression, it tells me true or false, and then the index I was incremented. So that caused the fact that when we realize that we are at the end of the string, we have already incremented I. In this version, which I'm going to rewrite here very fast, dereference S plus I, this is not the case at all. Okay? Sorry, dereference S plus plus. This is not the case because we are advancing in the string, incrementing the pointer S, but we modify size only if we realize that we are not yet on the terminating character. So you have to be careful about those things. If we want this function to do exactly the same thing as the previous, then we would have to return size plus 1 to account for that behavior. So let's save, compile again, execute. There we go. We are back to the same exact, how to say, semantic for that particular implementation. So, okay, we have been exploring multiple ways to implement the same thing, okay, and this is pretty much it for, I'm going to put the code back on the screencast. This is pretty much it for this particular function. Okay, one last quick remark before to close with this this first video. We are going to illustrate one more solution that I decided to add at the last minute here. We are going to illustrate how we can do the same job using one more feature of pointer arithmetic, which we didn't have many occasions to use in class, which is computing the difference between two pointers. So here's how it works. I'm going to keep the same str length interface, of course. I still want to do the same job. I'm going to dereference S, increment the pointer, post increment the pointer S, but I'm going to try to get rid of this variable size. Okay, so I remove everything that relates to size right now. So how can I compute the difference of the I solved it out already. How can I compute the length of the string just using pointers? Well, I will need another pointer, char star, which I'm going to name start, okay, and initialize to S. So when you pass a string as parameter to str length, you have the pointer S and you have the pointer start, which is going to be pretty much the same thing. Both pointer S and start are going to point to the beginning of your string. Then you are going to dereference S until you reach the end of the string. You are going to keep incrementing this pointer, okay? This is going to be your loop. You do not do anything else in your loop. You don't count anything. So when you reach the end of your loop, you know that S is pointing actually to the mark of end of string in your character array. So what you can do now is take the address of S, subtract from it the address where the string started, and this is not going to give you a number of bytes. This is not going to give you a number of words or whatever in your architecture. This is going to simply tell you how many elements of this dynamical array are comprised between the start and the end address. So since we have an array of chars, this is going to tell you how many characters are comprised between the start and the end address. So I save this file. We're going to switch to the terminal once again, clear up this mess a little, compile, execute, and we have the same result. Okay, back to the code so that you can see it before I close this video. So these are like many different ways to do exactly the same thing. Okay, and we are done for this video.